Discuss 3.2 synthetic division. Break this down into the three parts. So first we're going to talk about synthetic division. So normally when I multiply two numbers or say two functions and then I add something to it, the answer is just going to be some function, right? So the answer is just going to be some function. Well, this is actually called the division algorithm. So if I'm actually dividing, right? If I'm dividing some number by another, say like 8 divided by 3, right? It goes in evenly. I can rewrite this, right? Is basically, 3 times 2 plus a remainder of 2, right? So that's what the division algorithm is. You have some kind of dividend, dividend, that's our original uh, function. That would be 8. Okay, and then we have our divisor, however you spell that, divisor, so that's what we're actually dividing by, so that'd be the 3, and then this h of x is called our quotient, and that's our answer, okay? So this is what we divide by, this is our answer in our division problem. But sometimes it doesn't come out evenly, right? So that's when we have a remainder. And so when we do synthetic division, it's kind of a faster way to do it. Once you get a hang of it, doing it faster and faster, it's usually, it takes some time to understand the kind of the process of it. But basically when we do synthetic division, our divisor, what we're dividing by, has to be in the form of ax plus b, or you can say mx plus b. It has to be linear, okay? That's a degree of 1. So it has to be linear. All right, so sometimes it can be written a few different ways. Here's one way to write it like this. That's going to be dividing polynomials, so you can use synthetic division because this is a degree of 1. It's a linear expression there. Same thing can be written like this. So let's go ahead and do one of these. Basically what you're going to do is going to take that divisor, what you're dividing by, you're going to set it equal to 0, okay? And you're going to solve what x is, right? So I'm going to add 4 to both sides, I get x equals to 4. And then you're going to do this little framework here, okay? And you're going to put that 4 down here. And then you're going to put the coefficients in order from, I think that's negative 150? Okay, we'll go with negative 150, I guess. It might not be right, but we can still do it, okay? So you start with the largest degree first, so that'd be cube, right? So you start with that 3, and then it's a degree of 2, and then I'm missing degree of 1, just a plain x, so I need to put a 0 in that spot. So whenever you're missing it, you need to put a 0 in that spot. Same thing with long division. And then my constant, negative 150. Okay, now this first row is my coefficients in order from largest to constant. Okay, and then in the second row, you're going to always start with a 0 here, and then you're going to add add the columns. Okay, so 3 plus 0 is 3, and then whatever lands in the third row, you're going to multiply by what our x equals. So 4, so that's 12, add these is 10, multiply by 4, that's 40. So basically it kind of goes in this zigzag pattern. You add, multiply, answer goes here, add, answer goes here, multiply, answer goes here, add 40, that's 160, you get a leftover of 10. So this is my new polynomial. This is my quotient, the answer. And because I divided by a linear term, degree of 1, well, x cubed divided by x, that would just equal x squared. So these are my new, these are my answers. These are my new coefficients of my answer, my quotient, which is, so then it would be 3x squared, drop down a power, plus 10x plus 40. Now that I'm at my constant, now I write my remainder. So that's plus 10 divided by, because it's a fraction, right? My remainder is always a fraction over what I divided by, x minus 4. And so that's asking you if you're just dividing it synthetic division. Okay, in the next video, I'll show you how to use synthetic division in order to get the remainder, use the remainder theorem.